So here, breaking of wire. So we are interested in breaking stress. Breaking stress. So what is force? Force is equal to stress into area. Force is equal to stress into area. So breaking stress is equal to, breaking stress is equal to force is equal to breaking stress into area. So actually this breaking stress is a constant. That is the stress at which some material breaks. For copper, this will have a value. For some other thing, this will have another value. For steel, it is going to be another value. So if you have this, when you buy shirts, the price tag they will keep using a wire, right? If you try to break it, what will happen? It is going to be very painful. So what we do, next time onwards, take the scissor knife, cut pannit eduko. Okay, but if you suppose if you want to snatch the chain, gold chain, you can keep it, will break easily, right? Correct or what? So breaking stress of gold, breaking stress of copper, breaking stress of steel, everything is different. That is the reason this is actually constant. Correct? So if we apply that much force for a particular area, then it will break. Clear or what? This is what is breaking stress. Done. So breaking force is actually breaking stress into area, and this breaking stress is a constant. Remember this. So there is something called safety factor. Safety factor is actually working stress divided by breaking stress. Okay, suppose for a material we might have fixed a maximum set of stress. Suppose in a factory, suppose if we are doing something, okay, we need to bring something to somewhere using some machinery, okay, a crane is using, okay, we will be allowing only a particular amount of stress. So that is called the working stress. So working stress must be what? Less than the breaking stress. Correct or what? So that is what? Okay, clear? So safety factor should be more. Safety factor should be more. Correct or what? So inga vandu safety factor should be more, children. Sorry. Okay, so this is mistake. Male and our no breaking stress should come. And here it is working stress. So when we say our safety factor is more, safety factor means more safety. So where it should come? Breaking stress should come on the denominator. So how much less this working stress compared to breaking stress, that much safe the thing is. Clear? So this is another thing. Okay, suppose say for example, one question, 1 millimeter diameter of 1 millimeter breaks under a 1000 Newton. Okay, if you give 1000 Newton force, 1 millimeter diameter, okay, if the wire is of 1 millimeter diameter, it will break. Okay, another wire of the same material, but another wire, here this time the diameter is 2 millimeter. It breaks at what tension? This breaks at what tension? So what is force? Force is equal to breaking stress into what? Area. So breaking stress is constant. In area, pi is also constant. 1 divided by tension 2 is equal to what? R1 square divided by R2 square. R1 is 1000 into R2 square is 2 millimeter, no? So 4 millimeter square divided by, this is going to be 1 millimeter square. This is what is the second tension. The answer is going to be how much? 4000 Newton. Clear? So breaking stress, that time you need not think that only Young's modulus is constant. How come stress? Without stress, how you will be able to find the answer? Need not think like that. In this case, breaking stress is constant. Clear or what? Understood? Done. Okay children, now see, we have considered all these change in length, change in ratio, all that in the assumption that there is no change in the area. Okay, see, the change in length itself is very small. Change in length itself is very small, so we were neglecting the change in area. But sometimes what happens is extension will become double. Volume will not change, no. Say for example, 2 centimeter cube of a copper wire is given. A force is applied. Definitely, if there is change in the length, the area will be associatively reduced to maintain the same volume. So if they mention in the question, we have taken this much volume of copper is taken for this much extension is happened, then in that case we should apply change in, we should consider the change in area also. You should consider the change in area also. Okay, so next heading is Poissons ratio. Okay, so Poissons ratio. Okay, suppose Poissons ratio sigma or any symbol for Poissons ratio if we use, I am using sigma, is equal to nothing but lateral strain divided by longitudinal strain. Lateral strain divided by longitudinal strain. This is what is Poissons ratio. Okay. Okay, so what is lateral strain? Lateral strain means lateral, longitudinal or linear. This is lateral. Correct or what? So lateral strain, suppose if this is the a wire, a portion of wire is this, a portion of wire is this. Okay, now suppose if we are applying force on this is connected to a rigid support, say for example. Now what will happen is, suppose if this is the initial dimension, the final dimension will be changed to this, like this. So if this is the original length, then this is going to be the change in length. If this is the original diameter or radius, if this is the original diameter, then the changed diameter is this one, this minus this, correct or what? Okay, suppose if we are taking only that change, only the change, then what we should consider, this is going to be the new diameter, no, not the new diameter, change in diameter. I am putting this as delta D, delta D, original diameter divided by change in length, original length. So this is what is Poissons ratio. Okay, and since this is decreased, we used to put a negative. So its value is given as -1 to 0.5, -1 to 0.5 as theoretical value. Theoretical value. Experimentally, this is almost equal to 0.2 to 0.4. Okay, all these things, if you know, then if you know all this formula, then you will be able to answer the questions that are coming from this. Done. Over. Okay, next put the heading torsion of cylinder. takes this figure. Okay, see children, this is nothing but torsion. Torsion means one end will be, okay, just see, if you take a sponge, one end if you are holding like this and if you are twisting, what will happen? One end will be twisted, other end will be fixed. Okay, so when I twist, on the topper side there will be one angle twist will be there, bottom side also what will be there? Shear effect will be there, shear effect will be there. So here this is theta and this is phi. Okay, so angle of twist and angle of shear. So this is actually, see, when we were studying, what was this angle? Theta or whatever it may be. Angle of shear, angle of shear. So suppose if this side is fixed, see, this is one side, this side it is fixed, this is fixed. I am applying force in this direction. So here also this side is fixed, I am applying in this direction. So looking from the fixed end, whatever be the angle change is happening, there I was looking like this side is fixed, this angle was angle of shear, this time top it is fixed, and then I am looking from above, this angle is angle of shear or what? Okay, so phi is the angle of shear, and for here this is twisting angle, twist. So theta is the angle of twist. Oh, now arc is equal to, what is the formula? Arc is equal to what? Radius into angle. Arc is equal to radius into angle. Fine. When I look from O, the arc is equal to, when I look from Q, the same arc. So arc is here, arc is AB, arc is AB, this is the arc. So கண்கள் பாட தோணுதில்ல? ஓகே, இப்போவே தூங்கிட்டு இருக்கு, பாடனா எழுந்திரிச்சிடுவாங்க. வாட் இஸ் கோயிங் ஆன் ஹியர், என்ன டிசம்பர், என்னமோ ஒரு குரல் வந்துச்சு, பயமாகுது. ஓகே, ஜோம்பி. இங்கே ஒரு கண், இங்கே ஒரு கண், ரெண்டு கண்கள் இருந்து பார்க்கும்போது என்ன புரியுது? என்ன தெரியுது? அழகான arc. I thought something else. Okay. Arc AB. Okay. Arc AB is equal to radius into angle. Okay. So first we will say so முதல் கண்ணில் இருந்து பார்க்கும்போது when we look from O, what is arc? R theta. Correct or what? இரண்டு பார்க்கும்போது Q இல் இருந்து பார்க்கும்போது what? theta வா? L5. மூன்றாவது கண்ணில் இருந்து பார்க்கும்போது என்ன தெரியுது? பாப்பாஸ் அண்ட் பாப்பீஸ்? theta is equal to L5. Okay, remember this. Suppose R is asked, L5 by theta. L is asked, R theta by 5. Based on that, we will be able to do. So in this case, angle of shear is equal to, in this case, suppose if they ask angle of shear is pi, this is going to be R theta divided by L. Okay, then okay, clear? So all these things, okay, remember all the concepts, which angle, everything. Okay, direct application, direct questions. இந்த சாப்டருக்குள்ள என்டர் ஆச்சுன்னா பிரமிடுக்குள்ள என்டர் ஆகிற மாதிரி தான். இப்போ முடியும் முடிஞ்சாலும் ஒவ்வொன்றா கொஞ்சம் வந்துட்டே இருக்கும், முடியறதில்லை. Hysteresis loop. கேள்விப்பட்டது இல்லையோ? Magnetism. Okay. So here the hysteresis loop which we are going to study here, this is nothing but suppose here also again just like a stress strain graph, no? Stress strain. Okay, so what is this actually? When you apply stress, what will happen? Some strain will be there. Again, if you are increasing the stress, strain will be there. Finally it will be reaching some point. So when we reduce the stress, strain will be reduced. So suppose, say for example, say if it is 10 Newton per meter square, which what is this actually? நம்ம எடுக்கும்போது this strain is how much? Maybe 5 millimeter னு வெச்சுக்கோங்க. So increasing the stress, we are increasing the stress meter square, 10 Newton per meter square, likewise we are doing. But when we are decreasing the stress, say here this is 15 Newton per meter square. when you decrease, when it becomes 10 Newton per meter square, the strain will not be seen. புரியுதுங்களா? In the route, we were moving in this route. While coming back, we took another route. Some other purpose was there. Route மாறிடுச்சு. Okay. So எல்லா நமக்கு என்னெல்லாம் கேரக்டர் இருக்குதோ சேம் கேரக்டர் they have. So இப்படி ஒழுங்கா போயிட்டு இருந்த ஆள் திருப்பி வரும்போது ரூட் மாறி வந்துட்டு இருக்கு. Clear? So the thing is nothing but the corresponding strain will be different, children. Corresponding strain will be different. This time this is going to be maybe என்ன வருது? For this time the strain will be, instead of 5 millimeter, this could be 10 millimeter. Likewise, finally when it reaches the original dimension, it will appear like a what? Loop. That is called hysteresis loop. For different material, this thickness will be different. So based on this thickness, we will find application for all these. So the thing which is used for making tire, the thing which is used for making machineries, so based on the application, we will be using adhik tanda mari materials. Clear or what? That is what is hysteresis loop. Okay, another thing is the area of this loop. No, area of loop, area of the loop is actually work. So we prefer this kind of material for making tires of the car, otherwise it will get heated up very fast. Okay, this thing will be used for machinery purpose, not for making machines, but in order to what we will use washer kind of things. No, if one machinery is kept, between the machinery and the hole there will be this kind of materials. So the vibration of the machine, this will be able to handle vibration of the machine. This thing will be able to handle this. Just for your understanding purpose. Okay, புரிஞ்சு வச்சுக்கோங்க. Okay, clear? Done? Okay, children, done. So now put the heading application of elasticity. Application of elasticity. Okay, so one thing is number one, suppose if you are trying to make a crane. Okay, crane. Okay, suppose if you say that the capacity of crane is going to be 10,000 kg. Okay, this crane should be strong enough to handle how much? 10,000 kg. Clear? Now if we use steel, what is the tensile strength of the steel on an average? tensile strength of the steel. Suppose if we write this as 2 into 10 raised to 6, okay, Newton per meter square, say for example, okay, if they have given like the tensile strength of the tensile strength means stress, okay, the stress it can handle without changing the dimension, okay, is equal to 2 into 10 raised to 6 Newton per meter square. Now what should be the diameter of the rope? So what we'll be doing, this crane will have a rope, okay, it will be able to lift the things. That rope should be so strong, and if we could use steel will be rigid, no? How we will be able to wind it? Just like a thread, we should keep it somewhere, no? Otherwise crane will be taking like this, it will be doing this, no? Entire area will be damaged or what? So what we do is, we will be making very thin wires, and we will be making these thin wires into a small, very thin wires we will make into small kind of wires. Then these small wires will be joined together. So this will be stretching. So suppose maybe this kind of wire, this size, but it is steel. So it is made of thin wires, so this will be flexible also. That is how it is made. Now children, look. Suppose this yield strength of this steel, what is this actually? Breaking stress. யாரும் நீங்க பிரேக்கிங் ஸ்ட்ரெஸ் பிரேக்கிங் ஸ்ட்ரெஸ்ஸாக இருந்துச்சுன்னா கரெக்டாக இது கொடுக்கும்போது வாட் வில் ஹேப்பன், இட் வில் பிரேக். ஸோ yield strength is nothing but the stress level without changing dimension. Permanent change in dimension should not happen. Our yield point, right, that the point is where proportionality limit is met. Okay, that will be the maximum thing we will be giving. Okay, so it should come back to original dimension. Small change in dimension only should happen, that also should come back. Otherwise long run it is going to be, we cannot make it again and again, right? So expensive. So this is equal to what? Force by area. So this stress is equal to what? Force divided by area. Force divided by area. Now what is this force? 10,000 kg force is going to happen. Okay, we are going to put 10,000 kg. So that much force is going to happen here. So what we will put? 10,000. G also will come, 10 divided by 2 into 10 raised to 6. Okay, 2 into 10 raised to 6. This is going to be area. So what we do? Pi r square is equal to 10,000 divided by 2 into 10 raised to 6. Okay, so what we do? R square is equal to 1, 2, 3, 4, 5. 10 raised to 5 divided by, this is going to be 10 into 10 raised to 4 divided by 2 into 6. So if we cancel, this will be 5. So okay, so R square is going to be 5 into 10 power minus 2. So R is equal to pi is also there. Okay, here. So this is going to be pi into, okay, so pi will come, pi into how much? 5 into 10 raised to minus 2. So some value we are going to get. Into 2 is the diameter.
Pi is in denominator.
Pi is in the denominator. Okay. Okay. Correct or what? This is correct? Yes. So something we will be getting like this. So diameter, say for example, the true value will be in point. So that is the reason is I have taken this is, I think this is going to be 2 into 10 raised to 8 or something. Okay, let us correct it as, put it as 10 raised to 8. Let it be there. 10 raised to 8. Okay, then 10 raised to 8. Okay, leave it. Okay, let it be like this. No worries. So whatever answer we are getting, suppose say for example, if we are getting not this calculated answer, but I am telling diameter is equal to say 1 meter if we get. Okay, diameter is equal to 1 meter, then that much should be the diameter of that rope. So practically speaking, how much? Okay, say for example 0.25 meter or something. Okay, so that much we will be able to. So we may not be giving this much precise diameter also. We will take a little bit extra precaution also. Everything should be a little bit extra considering the safety measures. So protocols are there. Okay, in order to make crane, this much should be its tensile strength, this should be the materials, all these protocols given by the government of that country while making, because all these things matters safety. Clear or what? Okay, so they can give anything. Okay, so this is given in NCERT. Last 2 to 3 pages completely based on crane, bridge, all that. So please understand this. Based on the value of capacity, the yield strength of steel, I have taken some value. And I found the area. So in NCERT, this is given as 300 into 10 raised to 6. Okay, yield strength. So associatively, that kind of answer we will be getting. Shall I erase this? Consider this as a beam, children, beam. what is beam? If a building is constructed, this corner one pillar will be there, this side another pillar will be there, a beam will be made. Suppose if we are not putting wall in between, what will happen? This will slowly undergo depression. Manavaliya. What will happen? Just consider beam as well as bridge. Okay. The shape will come to this. So from the center of the previous structure to the center of the changed structure, this is called a depression. Okay. So the formula for depression is given in the book in NCERT. Only this much, nothing else we need to understand. Okay. So here this is the length of the beam. This is the length of the beam, and this is breadth, this is actually depth. Okay. Length, breadth and depth. Okay, now should we decrease this or not? We should decrease this, right? We should decrease this. Look at the formula. If we increase the length, what will happen? This will increase. If we increase the length, this will increase. If we increase the length of the bridge, depression will increase. Correct or what?
Yes, sir.
Correct, then if we increase this breadth, okay, depression will decrease. Correct or what? Suppose if we increase this depth, that is, if I want using same amount of cement, metals and soil, if I want, I can if I want, I can make like this. If I want, I can make like this. Which is better according to the formula? Here, this is what is depth. This is what is depth. This is another breadth. This is length. So here, this depth is coming in cube. This depth is coming in cube. So the same material, with the same expense, what we do? We are interested in making the beam in this shape. Okay, so that is the point here. Clear or what? Okay. So stress is equal to force by area. So if we increase the area, what will happen? If we increase the area, stress will come down. Stress is the cause for change in dimension, correct? Linear change, volumetric, whatever it may be. If stress is there, there will be change in dimension. True. So in constructions, if the stress is less, then the change over the long period of time also we can reduce it. So adukaha, when you make pillars, okay, when you make pillars, suppose if you make a pillar like this, and if you make a pillar like this, which is better? இந்த பில்லரோட பேர் வந்து திவ்யா. இந்த பில்லரோட பேர் வந்து மனோஜ். ஓகே, which is better? Manoj. Manoj than a better. Area is more, stress will be less. Correct? Ipdi pillar, if we start making pillars like this, when I move this side, here one pillar will be there, here another pillar will be there. Okay? Oor pura enna irukum pillar, the land of pillars, no, what we will be getting name. Correct or what? So what we are doing is we will ematal, adu namak palakkamai pochilla. What we will do like this. Like this we will be doing. Only where the contact is there, that there we will be increasing the area, and where in the middle part we will be decreasing. So most of the pillars which you have seen, you will understand. See, there some work will be done on the top and the bottom. You will be thinking, oh, they are decorating the house. Mudiyadu, panama mudiyadu, no other go. Okay, you will be forced to do that. Clear? So that is the idea. Wherever this is done, there we have to just do some decoration and manage. Okay, right? So this is called buckling. Okay, this is called buckling. 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 Okay, so otherwise what will happen? Slowly this will become like this. Again, ये मारी आइडो. Clear? Okay, done. Shall I erase this? Finding maximum height of mountain. Finding maximum height of mountain. Okay, see children, elastic limit of a typical rock is 3 into 10 raised to 8. What is elastic limit? So okay, okay, look here. Suppose rock, mountain will be rock, no? Mountain will be rock. So if its weight is too much beyond a level, what will happen? Slowly this will disintegrate. if that much weight it cannot handle, what will happen? It will come down a little, it will expand a little. So what will happen if this is the structure to become? What will happen if it cannot handle, the elastic limit cannot handle this much? What will happen? It will expand a little and the height will come down. So finally these process will happen. We don't need to do in nature, this will happen. So this will happen. Finally, if it is settled like this, then we can say elastic limit is nothing but again what is this? This is stress. Okay, this is force by area. Can I write H rho G also? H rho G also I can write. So if the elastic limit of the rock is 3 into 10 raised to 8, this is equal to H, which we do not know. Instead of measuring it fully all the way into this density, we will study at a place, we will be studying about the density of that material. We came to know that this is 3 into 10 raised to 3 into 10. So if we do this, we will come to know that this if we cancel, we will be getting 10 raised to 4. So how much is this? 10,000 meters, right? 10,000 meters. So in this way we can calculate the height of the mountain. So this, in this way they have given. Okay. So there is something called interatomic force constant. Okay, interatomic force constant. So suppose if this is potential energy and if this R is the distance between the molecules, okay, if R is the distance between the molecules, so for some area, for some distance, if the potential energy is positive, potential energy is positive means force will be attraction or repulsion. So if this is positive, attraction or repulsion? Repulsion. So what will happen? At very small distances, repulsion will be there. So beyond a distance, attraction will happen. So here the kinetic energy is more. So atoms and molecules, will they prefer more kinetic energy or less, more potential energy or less potential energy? Less potential energy. Less potential energy. Correct or what? So they will come and like what will happen? Energy will be minimum. Potential energy will be minimum. So at a distance R0, the distance between the atoms or molecules, so same procedure for molecules as well as atoms. Okay, what will happen? The kinetic energy will be minimum and this will be maximum stable. Okay, so again, if the distance between the molecules increases, the potential energy will increase. So this will be stable at R naught. Just note down that graph. Okay, so that interatomic force constant K is equal to Y into R naught, where Y is the Young's modulus, R naught is the distance between the atom at a minimum potential energy. Technically, this is nothing but force per the distance, force per distance. Okay, just we will do a simple problem. The mean distance between the atoms of iron, is 3 into 10 raised to minus 10 meter, and interatomic force constant is 7 Newton per meter. What is the Young's modulus? So what is the answer this for children? 2.3 into 10 power dentina. Tension 10. 2.3 into 10 to the power dindin. Okay, see this. Finally, there are lot of relations. Okay, we could see. Derivations are not there, but this could see in every book. Okay, so this one is volumetric strain. volumetric strain is equal to longitudinal strain delta L by L plus 2 into lateral strain. Lateral strain is delta D by D minus. Okay. Young's modulus is equal to 3 into bulk modulus into 1 minus 2 into Poissons ratio. Poissons ratio. Okay. Clear? Again, Young's modulus is equal to 2 into rigidity modulus into 1 plus Poissons ratio. Poissons ratio is not moduli of elasticity. Moduli of elasticity is Young's bulk shear. Okay, done. Again, Young's modulus is equal to 9 into bulk modulus into shear modulus divided by 3 into bulk modulus plus shear modulus. Again, this is Poissons ratio is equal to 3 into bulk modulus minus 2 into rigidity modulus divided by 6 into bulk modulus plus 2 into rigidity modulus. Actually, no point in asking about that. Remembering the formulas will not make much sense like this, right? This kind of formulas remembering. So normally, but for safer side, clear concept they must ask. Okay, so did we miss anything in elasticity? Okay, so elasticity is done. So lot of problems can be worked out from this.